Good afternoon all. So after 2-3 minutes we are going to start our session week 3. So let's wait 2-3 minutes, then we will start. So let's start the session. This is week 3. Am I audible? Hello? Am I audible? Hello?
Yes, ma'am.
Okay. So we are going to start our session week 3 sensor and actuator problem solving session. I'm ARPITA BISWAS. So this is about me, that I am ARPITA BISWAS, and recently I am pursuing PhD in Electrical Engineering Department from Indian Institute of Technology, Jodhpur. And this is my educational background, that I did my MTech in Micro Nanoelectronics from IIIT Jabalpur, and I did my BTech in Electronics and Communication Engineering from West Bengal University of Technology. And this is the class schedule, every Tuesday 7 PM to 9 PM. So let's start the session. So if you have any doubt, then you can ask the question, and please unmute yourself and try to solve this question also. So first, coming to the question number 1, which among the following holds true for chemical wet etching of silicon wafer? So now comes to the first option. Etch rate in isotropic wet etching does not depend on crystallographic orientation. The second option is etch rate in anisotropic wet etching depends on crystallographic orientation. And the third option is bulk and surface micromachining can be performed. So what is the right answer? Only option A, only option B, only option C, and the fourth option is A, B and C both. So please unmute yourself and try to give the answer. Bakwawani Sankar. Meena. RCB fan. Please unmute yourself and try to give the answer. At least try. Shankar. Am I audible? Hello? Am I audible? Hello? Meena Kashyap, please unmute yourself and try to give the answer. Which among the following holds true for chemical wet etching of silicon wafer? Etch rate in isotropic wet etching does not depend on crystallographic orientation. Etch rate in anisotropic wet etching depends on crystallographic orientation. and bulk and surface micromachining can be performed. So among these three options, which is the right, which is true? At least try. Then I will solve. Bakwa Bhani Sankar.
Madam, I think B option is right.
Option B. Okay. Can you explain, please? Whatever is the right answer, this does not matter now. At least you can try. Why option B is the right answer? Meena?
Madam, I don't know. I just randomly
Okay,
select the answer.
okay. But see, for the first option, H rate in isotropic wet etching does not depends on the crystallographic orientation. So, do you know about isotropic wet etching? What is happening? And what is anisotropic?
No, madam.
Okay, see, in isotropic wet etching, when we dip the wafer into a solution, then in all direction equally it etch out the wafer. Okay, but in anisotropic, it particularly in one direction, it etch out the wafer or the substrate. So in H rate in isotropic wet etching does not depends on the crystallographic orientation. It is true because in isotropic wet etching does not depends on the crystallographic. It can etch in all direction. Also, for H rate in anisotropic wet etching, what is happening? It only a particular direction. It is etch out the wafer or the substrate. Okay. So it is depends on the crystallographic orientation. In a particular direction it etch out. And also in the third option, bulk and surface micromachining can be performed. So whenever this wet etching, isotropic or anisotropic wet etching is used, then bulk and surface both micromachining can be performed. So here the right option is the option D. A, B, C both are correct answer. Okay, now it is clear.
Okay, ma'am.
Okay, good. At least you tried. Good. So we are moving towards the next question. Bosch process is used in which chemical etch process? Reactive ion etching, deep reactive ion etching. Third option is the wet etching, and fourth option is all of the above. So this question directly taken from the lecture, video lecture. Then this process, Bosch process, is used in which chemical etching process? So do you have any idea which chemical process? At least try. Shankar? RCB fan. What is the right answer? Meena?
Yes, madam.
Try to give the answer. It can be right or wrong, but please try.
Deep reactive ion etching.
Yes, you are right. So Bosch process is used in deep reactive ion etching. Good. Next we are moving towards the question number 3. What do you mean by high aspect ratio etching? It is an alternate term used for through hole etching. Second option is that the right opening of the etching area is large. The third option is that the degree of anisotropy of the etch profile is high. And the fourth option is none of the above. So which option is the right answer? What do you mean by the high aspect ratio etching? Shankar? Please unmute yourself and try to give the answer. At first you try, then I will explain. Shankar? Meena? What is the right answer? You are not audible. Please speak loudly. What do you mean by high aspect ratio etching? Which one is the right answer?
The opening of the etching area is large.
Okay. See, the high aspect ratio etching is the degree of anisotropy of the etch profile is high. Not only the opening area is large. Okay. So the right option is the option C. The degree of anisotropy of etch profile is high. This is
And
called.
what is the high aspect ratio etching?
Yes. High aspect ratio etching is
ठीक है.
the degree of anisotropy of the etch profile is high. Okay, good. Next we are moving towards the question number 4. The LCR meter shown in lecture is described to have lower accuracy than the impedance analyzer. Which among the following is most accurate reason for the same? The first option is LCR meter is smaller than impedance analyzer. Second option is LCR meter measured using a 2-probe setup and impedance analyzer using a 4-probe setup. And the third option is LCR meter runs on battery while the impedance analyzer is powered from supply. And the fourth option is none of the above. So which one is the right answer?
Ma'am, option B.
Okay, good. Can you explain? Have you seen the LCR meter or have you seen the impedance analyzer? Shankar?
Ma'am, no idea to explain.
Okay. Meena?
Actually, ma'am, I haven't seen the video of week 3. So that's why I am unable to justify that answer, or I am not able to give any answer.
Okay. So no issue. You can try. Whatever is the right answer, you can try. Then I will explain. Okay. Vaibhavi, any idea? Which one is the right answer? The LCR meter shown in the lecture is described to have lower accuracy than the impedance analyzer. Which among the following is the most accurate reason for the same? First option is LCR meter is smaller than impedance analyzer. Second option is LCR meter measure using 2-probe setup. and impedance analyzer using a 4-probe setup. Third option is LCR meter run one battery while the impedance analyzer is powered from the supply. And the fourth option is none of the above. Vaibhavi, please unmute yourself.
Maybe
And
second option.
yes.
Second option.
Okay, option B. Okay, good. So the right option is second option. Then LCR meter using measure using a 2-probe setup and impedance analyzer using a 4-probe setup. Good. Next we are moving towards question number 5. Which of the statement given below are true? Electrical impedance is a complex combination of resistance, capacitance and inductance. And option B is impedance varies with frequency. So which one is the right answer? Option A is only A, second option is only B, third option is both A and B, and the fourth option is none of them. So what is the right answer?
Both options.
Yes, RCB fan, what is the right answer?
Both A and B.
Both A and B.
Sorry, you are not audible. Can you speak loudly?
Madam, both A and B.
Both A and B.
Okay, both A and B. Shankar, what is the right answer?
Ma'am, both A and B.
Okay. Okay, good. So the answer is both A and B. Next we are moving towards question number 6. So identify the wafer bonding techniques. First, anodic bonding. Second, cathodic bonding. Third is plasma activated bonding. Fourth option is direct bonding. So which among these identify the wafer bonding technique. The first option is only 1 and fourth option. Second is only 2 and fourth option. Third is only 1, 3 and 4, and the fourth option is all of the above. So please try to solve. What is the right answer? Meena, at least try.
Yes, ma'am.
Shankar, boy baby,
Ma'am, third option. 1, 3 and 4.
okay. Any other? Shankar,
No idea, ma'am.
okay. Meena,
First, 1 and 4.
okay. Boy baby, can you explain why option C?
Ma'am, because anodic and direct bonding is related to wafer bonding processes.
Yes.
I also thought plasma activated is a wafer bonding process,
Yes.
a technique.
Yes, you are
C.
right. So option C is the right answer. Like anodic bonding, direct bonding, plasma activated bonding. So we are moving towards question number 7. Which biosafety level is appropriate for research with microbes or infectious agents that pose moderate risk to laboratory workers and community and are typically indigenous? So, first option is BSL 1, second option is BSL 2, third option is BSL 3, and the fourth option is BSL 4. So this question is directly taken from the video lecture. So what is the right answer?
Ma'am, BSL 4.
Okay. Any other? Please unmute yourself and try to give the answer. Meena?
No idea, ma'am.
Okay. Shankar? Whatever is the right answer, you can try, na?
Hmm.
Shankar? RCB fan? Yes, Shankar?
Uh, good.
Your voice is not clear. So what is the right answer? Which biosafety level is appropriate for research with microbes or infectious agent that pose moderate risk to laboratory workers and the community and are typically indigenous? Hello? Shankar? So right option is option B, BSL 2. Next we are moving toward question number 8. Which statements holds true for a biosafety cabinet? The purpose of germicidal UV lamps in class 2 biological safety cabinets is to keep the interior clean when not in use. And option B is UV light not only kills microorganisms in the biosafety cabinet, but it also destroys living cells in your body. In particular, it can cause painful damage to both your skin and your eyes, even after its intensity drops below the effective level. So first option is option only A, the second option is only B, third option is both A and B, and the fourth option is neither A or not B. So please unmute yourself and try to give the answer.
Ma'am, both A and B.
Okay. Any others? Shankar?
Both A and B, ma'am.
Okay. Can you explain? Shankar? Vaibhavi?
Yes, ma'am.
Why option C, both A and P? Can you explain?
Because as the second option states that we are not supposed to keep the UV light on when we are working. So it is dangerous to our health. So second option. And first option, Also because UV light is used for protection, like to clean the cabinet, so to keep the interior clean when not in use.
Okay. Shankar? Meena? Meena? Yeah, you are right. The right option is option C, both A and B, because also the UV lamp can kills the microorganism in the biosafety cabinet, and it also can destroy the living cells in your body, and also it can damages our skin and eyes. And also the first option is also the right option, so the right option is both A and B. Next we are moving towards question number 9. Probing the required micron level precision can be facilitated using which tool? LCR meter, impedance analyzer, micromanipulator, and the fourth option is multimeter. So which one is the right answer?
Ma'am, impedance analyzer.
Okay. Can you explain why impedance analyzer?
Because as it has 4 probes, so it is and we can like go it can move in 4 XYZ direction axis, so it can be used for micro level probing, like we can cover minute details of it. So
Okay, so why not micromanipulator or LCR meter?
I'm not sure, ma'am.
Do you know about micromanipulator?
No, I don't know about micro manipulator, but I'm sure कि LCR meter won't be, मतलब if impedance analyzer is there, then we would prefer impedance analyzer over LCR meter.
Why?
Because LCR meter has 2 probes, so the accuracy is comparatively less than the impedance analyzer.
Okay. And where we use the multimeter? Do you know about it?
To check the voltage and current flowing.
The resistance.
Yeah.
And do you know anything about the micromanipulator?
No, ma'am. I haven't heard of it.
Okay. Shankar? At least try. Please unmute yourself. Probing that require micron level precision can be facilitated using which tool? Meena? What is the right answer? At least try.
I think you are right. Micro manipulator is used.
Okay. Do you
Because
know?
LCR and impedance analyzer, I think both are same, because they are used to measure capacitance, inductance, and resistance.
Okay. And what about micromanipulator?
Uh, I don't know much about that micro manipulator, but I know a little bit about LCR meter and impedance analyzer and multimeter.
Okay.
So that's why I choose that answer, micro manipulation.
But in video, okay, you have not seen the video lecture of third week, right?
Yes, yes.
Okay. But Vaibhavi, it is also described in the lecture, video lecture, na, about the micro manipulator, how it is working, where it is used, why it is used.
Ma'am, I don't recollect about the micro manipulator thing. Then I have to see the videos again.
Okay, okay.
But I'm sure for LCR meter and impedance
Okay,
analysis.
so you please see this video lecture again. I'm
Yeah.
suggesting you. Okay.
Yeah. So is the micro manipulator
Yes,
the
yes.
correct answer?
Actually, the right option is the micro manipulator. For the precision, they have used the micro manipulator.
Okay, ma'am.
Okay.
Sure, ma'am.
Okay. Good. So we are coming to the question number 10. Which among the following are types of transducer? First option is capacitive, second option is piezoelectric and piezoresistive, and the third option is thermal, and the fourth option is all of the above. So what is the right answer? Which among the following are type of transducer? So at first coming to the question, what is transducer? Do you know about transducer?
It converts one form of energy to another form of energy.
Okay. So what is the right answer here?
All of the above.
Okay. Do you know about the piezoelectric or piezoresistive sensor or the transducer? What is happening in piezoelectric or piezoresistive?
Mm,
But what is thermal? What is happening for the thermal transducer or
Um,
sensor?
Ma'am, in physioelectric, when a mechanical energy is applied, there is a change in the voltage, whereas in piezoresistive, when a mechanical energy is applied, there's a change in the resistance of the circuit.
Okay. And what about the capacitive or thermal? Do you have any idea?
In thermal, I think heat energy is converted into electrical energy.
Okay. Vaibhavi, any idea about thermal or capacitive?
Ma'am, I agree with what she said. For thermal, it will be something related to heat energy or heat energy.
Okay. And capacitive?
It will be used for measuring the displacement or the pressure or something related to that.
Okay. So the right option is?
All of the above?
Yes. Good. So the right option is all of the above. Here capacitive also a type of transducer. Also the piezoelectric and piezoresistive are the transducer, and also thermal. So the right option is option D. Next we are coming to the question number 11. In soft bake process, what is the temperature of hot plate? First option is 50 degrees centigrade, second option is 90 degrees centigrade, third option is 120 degrees centigrade, and the fourth option is 200 degrees centigrade. So,
Ma'am, option B.
okay. Any others? Meena,
Yes, ma'am.
what is the right answer? Yes, RCL fan. What is the right answer?
90 degree.
90 degree. Okay. Meena,
Yes, ma'am, 90 degrees.
do you know what is soft bake process? Why we require this step, and when we go for this process? Meena,
No idea, ma'am.
Vaibhavi, why we require this soft bake process?
To make the resistant, photo-resistant harder, to make it hard, to make it stiff, maybe.
So what is the difference between soft bake and hard bake? Also we can go for hard bake. No? It is also
The conditions are different, maybe. The temperature,
yes, there is
the
a basic difference in the temperature, but why we go for soft bake? What is happening? How we coat the wafer with photoresist? Do you know?
no, ma'am.
Okay. So we are taking a spin coater, then we keep the wafer, and photoresist is in liquid form. So when we put a drop of photoresist on the sample, then it is spread out and it's coated over the wafer. So at first it is in liquid form, so there is a solvent type, residual solvent is present also. So at first we go for soft bake at 90-degree temperature for 1 minute. So it will remove the residual solvent from this photoresist. Okay. So the right option is option B, 90 degrees centigrade at and for 1 minute. So next we are moving towards question number 12. In hard bake process, what is the temperature of hot plate? So first option is 50 degree, second 90 degree, third option is 120, and the fourth option is 200 degrees centigrade.
Ma'am, option C.
Okay. Meena? What is the right answer? At least try.
Yes, ma'am. 120. Option C.
Okay. RCB fan?
Yes, ma'am. Option C. 120
Okay.
degrees.
Do you know about hard bake? What is happening and why we require this process? Can anyone tell? When we go for this hard bake process? Meena, speak loudly. You are not
After we have
audible.
unloaded the mask, we do the hard bake process.
Can you repeat again?
After once we have unloaded the mask, so
Okay.
after that we use the hard bake process.
Okay. But why we go for the hard bake process? What is the need of it?
To increase the thermal, chemical, and physical stability.
Okay. But when we go for this process, like there is a mask, like, and here is my wafer. So after the UV exposure, we remove the we remove the sample and we develop. Okay, develop means it you remove the photoresist, whatever the type of the photoresist and the mask. So it remove the exposed portion or the covered portion. Then after it is called development. So after the development we go for the hard bake process before the etching process, right? Because we want in developer solution it is in liquid format also. So we want remaining at the remaining portion where we want to keep the photoresist. We want that it will acting as a mask layer. So that's why we go for the hard bake process. So we dip the wafer into the etchant solution and it can etch out the unwanted portion. Okay, so we can get the desired design. That's why we go for the hard bake process. And in the hard bake process, the temperature is 120 degrees centigrade and it is for 1 minute. So it is clear?
Okay.
Okay. next we are moving towards the question number 13. Which one is the oldest micromachining technology? The first option is surface micromachining. The second option is bulk micromachining. The third option is all of the above, and the fourth option is none of the above. So which one is the oldest micromachining technology? At first tell me what is surface micromachining and what is bulk micromachining. When it is called surface micromachining and when the technique is called bulk micromachining.
Ma'am, bulk micromachining is when bulk part of a wafer is removed.
Okay.
And surface micromachining is when we add a surface or it's done above the front layer. So when there's a addition to the existing wafer or only a small part is to be removed or etched.
Okay. So which one is the oldest micromachining technology?
Bulk.
Sorry?
Bulk micromachining.
Okay. RCB, what is your name? RCB fan. Hello?
Yes, ma'am.
Yes. What is your name?
Ma'am, Chetan Patel.
Your voice is not clear. Can you write or you can speak loudly? Okay, Chetan. So can we differentiate between this surface micromachining and bulk micromachining? What is the difference between the surface micromachining and bulk micromachining? Vaishnavi? Okay, she left. Meena, what is the right answer and what is the difference between surface micromachining and bulk micromachining?
Madam, I think surface micro machining is uses for thin film deposition, and in bulk micro machining structures, it is used for structures inside a substrate.
Okay. So as she told, Vaishnavi told that when we etch out the bulk part of the silicon, like this is a silicon wafer, then if we etch the bulk portion, the maximum portion, like we want to make a cavity or we want to make a diaphragm, right? This type of diaphragm is here. This type of diaphragm is there. So if you want to etch out and we want to make the diaphragm type structure, then we go for the bulk micromachining. It means we removing most of the portion or bulk portion of the sample or the wafer. It is called bulk micromachining. But when we are etch out some portion from the surface level, then this is called a surface micromachining. And the oldest process is the bulk micromachining. Okay, so the right option is option 2. The bulk micromachining is the oldest micromachining technology. So we are moving towards the question number 14. Which technique involves selective removal of substrate to produce mechanical components? First option is surface micromachining, second option is bulk micromachining, third option is all of the above, and the fourth option is none of the above. So please unmute yourself and try to give the answer.
First one, surface micro machining.
Vaishnavi?
Yes, ma'am, surface micromachining.
Okay. Can you explain why surface micromachining? At least try. Vaishnavi?
Ma'am, because bulk micromachining is used when we want to remove maximum part of the substrate, whereas surface micromachining is used to remove selected components or the small part. So maybe surface micromachining.
No, it is not the right option. The right option is bulk micromachining. So we want to selectively etch out the maximum portion. Okay, because when we go for the surface micromachining, there is some sacrificial layer or a structural layer. So when we go for the sacrificial layer, so some portion of the oxide layer we want to remove. So for the bulk micromachining, we selectively etch out. So the right option is the option B, bulk micromachining. So
Okay.
selectively remove the substrate to produce the mechanical component. So we want to, if you want to produce a mechanical component, so maximum part of the wafer or the substrate we want to etch out, right? So the right option is bulk micromachining. Next we are moving towards the question number 15. So the question is, chemical wet etching is popular because of high etch rate, low selectivity, high etch rate and high selectivity. Third option is low etch rate and low selectivity, and the fourth option is low etch rate and high selectivity. So what is the right option? Can anyone tell what is the difference between dry etching and wet etching? What is happening for dry etching and what is happening for the wet etching?
Ma'am, chemicals are different for both the process.
Can you speak loudly? Your voice is not clear.
Chemicals are different for both the processes.
Okay, chemicals process, like which type of chemical we used for dry etching or the wet etching?
For wet etching, potassium.
No,
KOH
I'm not asking about exact name. I'm asking about the type of the chemicals, like it is gaseous or liquid, or it is any other or form.
Liquid is used for wet etching.
Yes, and for dry etching.
Gaseous, maybe.
Okay, and any other option? Any other type of chemicals? Or like, actually when we want to go for the dry etching process, the plasma or the gaseous form. Okay, the chemicals are in plasma or gaseous form, then there is no liquid format is present. So for wet etching, the liquid type of chemicals are used for the for etching or removal of the some portion of the substrate. So for chemical etching, wet etching is popular because of, so coming to the question, because of which option? The high etch rate and low selectivity, high etch rate and high selectivity, or low etch rate and low selectivity, and low etch rate and high selectivity. At least try.
No idea, ma'am.
Meena, what is the right answer? Ashwini, what is the right answer? The chemical, oh, she left, he left. Chetan, what is the right answer?
It has good selectivity,
Yes.
but etch rate I'm confused.
Which option is the right option?
Ma'am, B maybe.
Option B.
Yes, ma'am.
Okay. So the right option is option B. For chemical weight etching is popular because of high etch rate and high selectivity. It selectively etch the or remove some portion of the wafer or the substrate, and etch rate also high. Because for dry etching process it is slower than the wet etching process, and it takes more time also. Also it selectively etch for chemical wet etching, it selectively etch out the substrate, unwanted portion of the wafer. Okay, so the right option is option B, high etch rate and high selectivity. Next we are moving towards question number 16. Which process starts with deposition of thin film that acts as a temporary mechanical layer? First option is surface micromachining, second option is bulk micromachining, third option is all of the above, and the fourth option is none of the above. So which process starts with deposition of thin film that acts as a temporary mechanical layer? So go through the question at first, then you can easily give the answer. Which process starts with deposition of a thin film that acts as a temporary mechanical layer? Please unmute yourself and try to give the answer.
And surface micromachining.
Can you explain why we go for surface micromachining?
Because in surface micromachining there's a thin sheet, like if we want to create a small substrate, like if we want to add something, so surface micromachining is used. So that is done using a thin film which is added on it, and that is etched. So that's why maybe.
Yes, you are right. So the right option is surface micromachining. So when we go for the surface micromachining, at first we deposit some material on the substrate, on the surface of the substrate. Then we go for the other fabrication process, like at first we coated this or we make some sacrificial layer, then we go for some structural layer, then we remove some sacrificial layer from there, and we prepare our devices. So the option A is the right answer, because for surface micromachining at first we deposit a thin film that acts as a temporary mechanical layer. It means it temporary there is a layer, oxide layer or something else, then after prepare the device we remove this layer. So it is it can be called as a sacrificial layer also. So option A is the right answer. Next we are moving towards the question number 19. So disadvantage of the surface micromachining. First option is mechanical properties of most thin films are usually unknown. Second option is the reproducibility of their mechanical properties. Third option is all of the above, and the fourth option is none of the above. So please unmute yourself and try to give the answer. The disadvantage of the surface micromachinings are mechanical property of most thin films are usually unknown, reproducibility of their mechanical property, or all of the above or none of the above. So what is the right answer? Chetan,
Ma'am, all of the above.
can you explain?
Ma'am, because thin films, whatever thin films are used, we don't usually know the mechanical properties. and to reproduce those mechanical properties is difficult. So
Okay. Meena, what is the right answer? At least try. Chetan?
Ma'am, unknown mechanical property. Option
Option?
A. Option
Okay. So option B is the right answer. Sorry, option B is not the right answer. All of the above is the right answer. Option C, because for surface micromachining, mechanical property of most thin film are usually unknown, and also the reproducibility of their mechanical properties. So all of the above is the right answer. So next we are moving towards question number 18. Evaluate whether the following statement is true or false. The wafer bonding is a method that involves joining two or more wafers together to create a wafer stack. So first option is true and the second option is that false. So what is the right answer?
A. True.
True. Any other?
true, ma'am.
So can anyone explain what is wafer bonding process? What is happening for wafer bonding? Vaishnavi, at least try, na? The word wafer bonding, here we getting what information? Chetan?
Ma'am, that they are grouped together.
Okay, group together. It means there is some bonding between these wafers, or some when. So here see the sentence. The wafer bonding is a method that involves joining two or more wafer together to create a wafer stack. It means not only the wafer, also it at first if we go for the make the device, or we are going for like stack type things. Like if we want a wafer, we want to bond it with a glass substrate also. In that case also we are going for the wafer bonding process. Actually it involves the joining two or more wafers together to create a wafer stack. So the right option is true. Next we are moving towards the question number 19. BHF is used to etch silicon dioxide, remove the photoresist, and none of the above. So at first tell me what is the full form of BHF, and it is used for what? Chetan?
Buffer hydrofluoric acid.
Okay, buffer hydrofluoric acid. And
Yes.
why it is used?
Ma'am, for SiO2 etching, silicon dioxide etching.
Okay, silicon to remove is silicon dioxide. Vaibhavi, what is the right answer?
Ma'am, SiO2.
Okay. Can anyone tell a process which where silicon is etched out? Any etching process where silicon is etched out? Meena? Have you heard about TIMA?
No one.
Yes, ma'am. It is a chemical used for wet etching.
So this is used for what? What is the things that we have to etch? That's why we are dip the wafer into the TIMA solution. Silicon or silicon dioxide? For TIMA, what we etch out?
I guess silicon.
Yes.
So entire KOH is also used to etch out silicon, right?
Yes.
Okay.
The TIMA, KOH, both are the wet chemical etching process. So we remove or we etch silicon by this process, right?
So ma'am, BHF is also wet etching only, na?
Yes, it is a part of wet etching because for wet etching, liquid type of chemicals we are etching, we are used now. When we
Yeah.
are go for the plasma or the gaseous form we are taking, in that case,
Actually,
it is called dry etching. Okay.
Okay.
So what is the right answer here? The silicon dioxide. Can anyone tell me when we want to remove the photoresist, which type of chemical we used? Any of the chemical name we used for remove the photoresist?
Acetone?
Yes. Any other? Also IPA also used for the removing the photoresist. Okay.
Can you repeat the name?
IPA, isopropyl alcohol.
Acha. Okay.
Okay. And do you know about photoresist? What type of photoresist is present? And now for what type of photoresist we it means the positive photoresist and the negative photoresist. What is the difference between positive photoresist and negative photoresist? Can anyone explain? Vaibhavi? Meena?
No idea.
Chetan, what is the difference between positive photoresist and the negative photoresist?
Ma'am, it depends upon what is the bright field.
No, actually I'm not asking about the mask. I'm asking about the photoresist type. What is the minimum? What is the difference between the positive photoresist and the negative photoresist? When we cover some portion with positive photoresist, what is happening? When we go for the UV expose process,
So ma'am, for positive photoresist, the area that is exposed to the UV light, it develops faster compared to that which is not exposed to UV light.
which is covered. Okay.
Yeah.
Yes. And what is happening for the negative photoresist?
It's the opposite. The non-exposed gets developed faster compared to
It means the cover area dissolve faster or etch out faster, right? And the exposed portion is remaining. It is called negative photoresist. And what about the bright field mask and what about the dark field mask? Chetan? Now coming to the question, what about the dark field mask and what about the bright field mask? But maybe at least try na. There's a two type of mask is present when you go for the photolithography. One is bright field mask. There is a we want a structure on our device like a ID pattern we want. In that case, there is a structure of the component and the background. Okay. So if the background it is in black color and the transparent area is only the pattern we want, the maximum portion is black and only the pattern we want it is the transparent form, then which type of mask it is? Yes.
Ma'am, can you repeat once?
Like if we want a structure, we want to fabricate a ID pattern, okay, one a polysilicon or something else, one nichrome nickel chromium, one ये ID pattern or ये micro heater we want to fabricate. So we are taking a mask. In the mask, the maximum the background area is in black color. Only the desired pattern we want, the design ID pattern or something else, the heater pattern, it is in transparent, and the maximum it is in dark. So what type of mask it is?
Ma'am, it will be dark field mask.
Yes, it is dark field mask. And if it is the opposite is happening, only the pattern we want, this is in black color or something chromium or something else is there, and the maximum portion is transparent, then it is called bright field mask. Okay. So we are moving towards the question number 20. Soft lithography is a technique for fabricating or replicate structure using PDMS, the elastomeric stamps, the mold, and the comfortable photo mask, or all of the above. So at first, coming to the question, what is soft lithography? Do you know what is lithography at first? Can anyone tell me what is lithography process?
Ma'am, to transfer a pattern layer to a chip.
Okay. Any others? What is lithography process? Boy baby, what is lithography process? At least try, then I will explain.
The process of transferring a normal wafer to a desired output.
See, there is no transparent something. It means we are taking a glass substrate, or either we are taking a wafer, silicon wafer or something else. Okay. Then what is lithography? It is a technique where we transfer a pattern on the layer. There is a layer or something, the silicon or silicon dioxide, then we want to make a structure like a ID pattern for the electrode or the micro heater. Then what we do? we take a mask. In the mask there is a pattern. Okay, so then we UV expose on this mask, and the UV light is coming through this mask to the wafer or the substrate or the layer. And there is a 3 type of also photolithography processes here: the projection lithography, the contact lithography, and also the proximity. So in the type of the photolithography, whatever we want, this type of photolithography process we can follow. Then what happened? There is a structure. This structure pattern is generated on the photoresist layer. Okay, so then what happened? Then we go for the developing process. Then whatever which type, in it depend on the photoresist type, it is positive or negative, it removes some portion of the photoresist. Then after that we go for the etching process. After the hard bake process we go for etching process. Then we etch out the unwanted portion, and then we remove the remaining photoresist. Then we get the actual structure of the ID pattern or the micro heater pattern. Okay, so it is a patterning process. The mask is used here as a patterning process. When we expose the the design is coming from the mask to this wafer. So what is now coming to the question, what is soft lithography? It is only the lithography process that is happening. So what is soft lithography? Any idea? At least try. What is soft lithography process? Chetan? What is soft lithography process?
Ma'am, it uses basically elastomeric materials such as PDMS, and it is called soft.
Can you repeat?
Ma'am, it uses PDMS elastomeric type material, hence it is called soft.
Okay, okay. And what about mold?
Yes, ma'am, molds also and comfortable photomask also.
Yes. So the right option is?
Option D.
Okay. But what is mold here?
Ma'am, mold is after certain process. We have a more like a shape kind of a thing for made of silicon that can be used many number of times.
Yes. Actually, this is a pattern, like the shape type of pattern, where the silicon, we can take the silicon or something else, then we etch out some portion and we make a structure. Then using this mold we also use the PDMS. Then we remove or different this PDMS, and we make a bonding between something else with this PDMS. So mold is used as a shape, right? So what is the right answer here?
All of the above, ma'am.
Okay. So next we are moving towards the question number 21. Number of probe in impedance analyzer is 2, 4, 5 or 6?
Ma'am, 4.
Okay. Chetan, what is the right answer?
Ma'am, option B.
Okay. Can you give me a basic introduction about the impedance analyzer? Why we go for the impedance analyzer, why we are not using the LCR meter, and what type of things we can measure from the impedance analyzer?
I have no idea.
Boy baby.
Ma'am, impedance analyzer is an instrument we use to measure the impedance or capacitance and all. Here we have four probes, and it can move itself in three axes. So there is accuracy while measuring impedance using this instrument.
And what about the LCR meter?
Ma'am, LCR meter has two probes, so comparative to impedance analyzer, it gives less accuracy.
So what type of things we can measure for LCR meter?
Um, Capacitance, resistance, inductance, and
Okay. So we are moving towards the question number 22. Number of probe in LCR meter. So what is the right answer? 2, 4, 5 or 6?
2, ma'am.
Okay. Boy baby?
2, ma'am.
Chetan, can you explain now, as earlier the Vaibhavi also explain about the LCR meter or the uh, impedance analyzer. Now can you explain what is the basic difference between the impedance analyzer or LCR meter? If you want a accurate result, then which process we will follow?
Ma'am, for accurate result, impedance analyzer is used because it has four probe setup and maybe it can analyze in three directions. And LCR meter has low accuracy because it has two probe setup.
Oh, okay. So next we are moving toward the question number 23. Which biosafety label is appropriate for sophisticated environment like hazardous pathogens or chemicals we are working with? BSL1, BSL2, BSL3 or BSL4? So this question is directly taken from the lecture video, that which biosafety label is appropriate for sophisticated environment like hazardous pathogen or the chemicals we are working. So please try to give the answer and unmute yourself.
Level 4, ma'am.
BSL4.
Yes, ma'am.
Okay. Any others? Chetan?
No idea.
No, actually the right option is BSL3. BSL3 is used, the biosafety label BSL3 is used appropriate for sophisticated environment like the hazardous pathogen or chemical we are working with. Okay. So next,
ma'am, when is level 4 used?
actually there three types of mainly three types of BSL level they have discussed in the lecture video: BSL2 and the BSL3. Where and BSL2 I think I have discussed earlier, na, where they have used the BSL2 type. And
Yeah,
for the
but
hazardous, but BSL4 type I don't think they have discussed.
okay,
You
ma'am.
can recheck the video also, but they have discussed about the BSL3 that if we are going for the hazardous pathogen or chemical, then in that case BSL3 is used, and also the where the BSL2 is used.
Okay, ma'am.
Okay. So we are coming to the question number 24. Why soft bake is required? The first option is reduce the solvent content in order to stabilize the resist film. The second option is make more resistant to wet chemical etching. And the third option is reduce the undercut of the resist during the wet chemical etching, or none of the above. So what is the right answer?
Ma'am, option A.
Okay. Can you explain what is the soft
Ma'am,
bake process?
because you told previously like it is used to reduce the amount of impurities and to make it more stabilized.
Yes. Chetan, what is the right answer?
Ma'am, soft bake is used for improving the edge resistance also, right?
Can you speak loudly? Your voice is not clear.
Ma'am, soft bake is used for improving the edge resistance also, right?
Soft bake is used for
Improving the edge resistance.
see why we go for the soft bake process. At first when we coated the wafer with the photoresist, then it is in liquid form. Then what we want to remove the solvent content, so the resist can stabilize. Okay, that's why we go for the soft bake process at 90 degrees centigrade temperature for 1 minute. And see, what is the second option? Make more resistant to wet chemical agents. No, this option is not right. And the option C, reduce the undercut of the resist during the wet chemical aging. No, it is also not the right option. So the right option is the reduce the solvent content in order to stabilize the resist film. Can anyone explain what if we want to develop or we want to make a or fabricate a device, what is the whole process? Can anyone explain? Then it can be clear to you. If you want a fabricated device, like the whole process. Vaishnavi, can you try?
Okay. So first we take the silicon wafer and silicon substrate. Then there's a layer of silicon oxide, SiO2.
If you take a silicon wafer, at first you will clean the wafer, na? Can you tell me a cleaning process? Any of the cleaning process?
No idea about the cleaning process, ma'am. Can you?
So there is a 2-3 types of cleaning process, like RCA1, if in organic or inorganic type of particles is present in the surface of the wafer, na? So in that case, RCA1, RCA2, there is a chemical process like ACl solution or something else, HNO3 something. This type of liquid chemical is used, and also the Piranha process where the H2SO4 and hydrogen peroxide also used, and and it is mixed with the DI water obviously. So there is a process like Piranha RCA1, RCA2 process is used for the cleaning the wafer. Okay. Then we go for the other process. So after cleaning, what we will do? Vaishnavi?
Yes, ma'am. So once the wafer is clean, then we use a layer of, we give it a layer of SiO2, silicon oxide.
Do you know the deposition technique of the silicon dioxide? So which type of technique we used?
Thermal oxidation.
Yes, thermal oxidation. And in thermal oxidation also there are 2 types of oxidation, like the which one is the slow? Do you know about the thermal oxidation?
Not sure, ma'am, about in depth about thermal.
Okay. See, there is a 2 type of technique. If we only taken the oxygen and we and also where we use the H2O or the vapor type of things now, so dry oxidation or something wet oxidation also present. So when we only taken the oxygen and oxygen gas and we react with the silicon wafer, it is called dry oxidation process. and there is a different type of oxidation process like wet oxidation, or where we take in the vapor, H2 vapor and the oxygen, and then it react with the silicon and it produces the silicon dioxide. Okay.
Okay,
So
ma'am.
but now coming to the question, what type of technique is better, and which is the fastest process? Do you know about it?
Ma'am, I don't know in depth about thermal oxidation. I have to read about it more.
Okay, then explain.
So once there's a SiO2 layer deposited, then we give the photoresistor positive or negative.
Hmm.
Once we have the photoresistor, we perform soft bake to give it more resistance. And then we use a bright field or a dark field mask, and we expose it under UV light. Once we have exposed it under the UV light, we put it in the developer. So where according to the mask, the unwanted part is removed.
So what is happening for which type of mask, or what is happening for the which type of photoresist? Here your concept will clear, na? So
Yes,
if we
ma'am.
use the bright field mask, what will happen if we use bright field mask and also we use the positive photoresist? What will happen?
So because of the bright field mask, the part that is exposed to the UV light, it will uh, regenerate, and the part that is transparent in the bright field will be left. The dark part of the bright field will be removed, uh, as it is positive photoresist.
So in positive photoresist, the covered area will remain, or it will dissolve, or it will etch out.
For positive photoresist, the covered area will remain.
The covered area will remain. Okay. For a negative photoresist and dark field mask,
The unexposed area will remain.
yes, the covered area will dissolve or the etch out, or the exposed area will become more harder. Okay, then but what is the next process?
So once we have received this, then we perform hard bake.
Okay.
And then we put it in an etchant acetone to remove the photoresist, and then we have a required result.
Okay. Do you know if we use the acetone or IPA, the isopropyl alcohol, to remove the photoresist? So sometime because of the hard bake process, now the trace amount of the some amount of the photoresist is present. So in that case, how we will remove this photoresist? There is a machine, and so we put the wafer into that. Do you know the name of this equipment,
No, ma'am.
which remove the unwanted portion of the photoresist? Because for the hard bake process, the trace amount of photoresist is remaining on the sample. So if you want to remove this photoresist, so we have to do some process or some equipment we have to use. Any of you know the process?
No, ma'am.
Meena or Chetan? Chetan?
No, ma'am, I don't.
Okay, so there is a equipment like sonicator. So we use sonicator to remove the unwanted portion of the photoresist, whichever is present now after the acetone wash or something. So we at first we take the wafer or the device into this acetone, and then we keep this beaker on the sonicator. then we keep some for the time. Then after that, the whatever the trace amount of photoresist is present, it become clear or removed. Okay. Now coming to the question, dry oxidation and the wet oxidation process. So which one is the fastest process? Like dry oxidation, only oxygen react with the silicon wafer and then it produces the silicon dioxide. And the wet oxidation process, with this oxygen, we use the water vapor, and then it react and it produces the react with the silicon and it produces the silicon dioxide. So which one is the good process? Or it means the silicon dioxide, the dielectric layer is the quality of the dielectric layer is good, or the oxide layer is good for which process, dry or wet? Any of you?
No idea, ma'am.
See, for dry oxidation, only oxygen is used and it reacts with the silicon. So here the process is very slow, but the quality of the oxide layer is very good. But where we use the water vapor now, then it degrades the quality of the silicon dioxide. But the process is very fast. The process also, you know, whenever where we are using the wet chemical etching or wet oxidation, it is always faster process because there is some liquid is present. Okay, here we are using the water vapor for wet oxidation process, but also it degrades the quality of the silicon dioxide, but the process is very fast. So if we want good quality of the oxide, then what type of process we will follow?
Dry oxidation.
Yes, dry oxidation. Next, coming to the question number 25. Why hard bake is required? Reduce the solvent content in order to stabilize a resist film. Second option is make more resistance to wet chemical etching. And the third option is reduce the undercut of the resist during the wet chemical etching. And the fourth option is both option B and C. So what is the right answer?
Ma'am, option B and C.
Yes. And Chetan, what is the right answer?
Yes, ma'am, option B and C.
Option? Vaibhavi, can you explain it? You also
Ma'am,
explained it earlier, but you can explain here also. Why you
Yeah,
go for the hard bake?
because as in the options, soft bake is used to make the resist film more stabilized. So to make it more resistant, we do hard bake. So option B and C.
Yes. So option D is the right answer, that the hard bake process make more resistant to wet chemical etching. Because at first, whenever we go for the etching, now wet chemical etching, we want more resistant, the more resistance photoresist. Otherwise, it will remove. Or when we go for the etching process, it also, whatever the desired pattern we want now, it also remove that portion also. So that's why we want more resistant on the photoresist. That's why we go for the hard bake process. And what is the temperature of the hard bake process? And what about the time? Do you have any idea?
120 degree for 1 minute.
Yes. Chetan?
Yes, ma'am, 120 degrees for 1 minute.
Yes, 120 degree for 1 minute. Then we go for the etching process and it remove the unwanted portion of the wafer or the design or the layer, and finally we remove the photoresist with acetone and we get the desired pattern. So coming to the question 26. Sacrificial layer is the layer of material used during the fabrication process to deposit microstructure. These are removed towards the end of the fabrication. The second option is the layer of the thin film material with which the microstructure are made of should have physical and chemical properties that are suitable for the desired application. And the third option is none of the above. And the last option is the all of the above. So what is the right answer? Tell me what do you know from the sacrificial layer word?
Ma'am, sacrificial layer, as the name only suggests, it is used as a matlab, to develop microstructures, and then it can be removed afterwards.
Can you give me an example of the sacrificial layer where sacrificial is used?
For surface micromachining,
Yes, for surface micromachining. And the name of the sacrificial layer, some like which material or what type of layer? I want to know the name.
Zinc oxide can be used as a sacrificial layer.
Okay, some oxide layer can be used as a sacrificial layer. And can you give me an example of a device where the sacrificial layer is used? Like which type of structure we want from using this sacrificial layer?
I didn't get your question, ma'am.
Like which type of structure? Like can you give me an example where we use the sacrificial layer? I want to know the name.
I don't perfectly know where it is used, or I have an example of it.
Chetan, do you know?
No, ma'am.
Like if you want a cantilever type of structure, no? Like this here it is used, then in this type of structure. So in between, if there is a structure, then we at first we deposit here the wafer, then we deposit, then there is a third layer, okay, the second layer, and in between also there is a layer. So if we remove the middle layer, na, this type of things can you can see. So this layer is like a cantilever type. So to form the cantilever type of structure, we can use this sacrificial layer. Okay.
Okay, ma'am.
So whenever the cantilever bend, then it also changes the some property, some chemical or the structural property of the cantilevers. So the result also different. So to make this type of device, we use the sacrificial layer. So what is the right answer here?
All of the above?
Yes, all of the above is the right answer. Because the layer of the material used during the fabrication process to deposit the microstructure. Here at first, for the sacrificial layer, we deposit a structure or the layer. These are removed toward the end of the fabrication. So after the fabrication process, now when we get the final device structure, we remove this layer. That's why it's called the sacrificial layer. And the layer of the thin film material with which the microstructure are made of should have physical and chemical property that are suitable for the desired application. Obviously, the chemical and the physical property of this material also will that are suitable for the desired application. Whatever the desired pattern we want, the chemical property of this layer also match with it. Okay, so the right option is all of the above. Next, coming to the question structural layer. the layer of the material used during the fabrication process to deposit the microstructure. These are removed towards the end of the fabrication process, or the layer of thin film material with which the microstructure of made of should have physical and chemical property. No, for the sacrificial layer, the layer is removed. So the option 1 is the right answer, and the layer is remaining there now. Just a minute. Yes, and the layer is remaining there. The layer thin film material with which the microstructure made of. It means the third layer where the microstructure is remaining, and the sacrificial which is removing. So option A is the right answer. Sacrificial is the layer which is removing after the fabrication process, but the remaining portion which is on the surface of the structure, this is called the structural layer. So question number 26, right option is option A. Now coming to the question, the structural layer. So the first option is the layer of material used during the fabrication process to deposit the microstructure. These are removed towards the end of the fabrication. So we know that if we remove some layer after the fabrication process, then it is called the sacrificial layer. But the layer of thin film with which, like there is a layer of thin film with which the microstructure are made of. The main structure, whenever we are going for the surface micromachining, the main structure with which the microstructure is made of. So main structure means it's remaining on the surface. It is not removing. It is remaining on the substrate, and it is the main part. Should have the physical and chemical property that are suitable the desired application. Whatever we are want to make, the cantilever or something else, this pattern, the chemical and the physical property of this material is suitable for this application. Okay, so the structural layer is remaining on the surface of the structure, and also it have the favorable physical and chemical property. Okay, so what is the right answer here? The structural layer is, boy baby, what is the right answer?
Option B, ma'am.
Option B, because option A, whenever the layer is removing after the fabrication process, this is called the sacrificial layer, but the remaining portion, the layer is remaining on the surface of the substrate. It is main part. This is called the structural layer, and also its physical and chemical property are favorable for the desired application. So option B is the right answer for the structural layer. So we are moving towards the question number 28. Which one is the first state etching process? KOH, TIMA, DRI, E, and none of the above. So tell me, what is the KOH process or TIMA process? It is wet chemical etching or it is dry chemical etching?
Wet.
And what about the DRI? What is the full form of DRI?
Dry. I don't remember, ma'am.
Dry reactive ion etch.
Deep reactive?
Deep reactive ion etching.
Ion etching. So it is a wet chemical etching or the dry chemical etching?
Dry etching.
It is a dry etching process. And what about the TIMA and KOH?
Wet etching.
What is the full form of TIMA?
Tetramethyl
Ammonium?
ammonium hydroxide.
Yes, ammonium hydroxide. So by this TIMA etching process, which layer we remove or etch?
Silicon.
silicon. So here, which one is the faster etching process? KOH, TIMA, DRI, and none of the above. At first, tell me which one is the faster process between the chemical wet etching and chemical dry etching?
Wet etching.
Yes, wet etching. So DRI is the dry oxidation, dry etching process. So DRI is not the correct answer. So TIMA and KO is the wet etching process. So among this KOH, TIMA, and the DRI, which one is the faster process? Try. Vaishnavi? See, the KOH is the faster etching process, but TIMA is slower than the KOH. But why we go for? Do you know why we go for the TIMA etching process? At first,
No,
see.
ma'am.
What? Why, baby? Are you telling
No
something?
idea, ma'am, why we use
Okay.
TIMA.
So you know, na, in DRI is a dry etching process and TIMA and KOH is a wet etching process.
Yes, ma'am.
Yes, so always wet etching process is faster than dry etching process. So the answer will be KOH or TIMA. But in between the wet chemical etching, KOH and TIMA, KOH is faster. But in case of TIMA, it directionally etch the silicon wafer. That's why the TIMA is used. Mainly the TIMA is used. So the faster process is KOH. But if we go for the silicon oxide, silicon etch, then we go for the TIMA etch. So the right option is option A, KOH. Now coming to the question 29. How many types of wafer bonding is used in fabrication process? First option is 2, anodic and cathodic bonding. And second option is 2, direct and cathodic bonding. The third option is anodic, cathodic and the direct bonding. And the last option is 3, anodic, intermediate layer bonding and the direct bonding. So what is the right answer?
Ma'am, last
Option D.
option.
Option
D.
Option D.
Okay. Do you know, can you tell me an example of a device where we use this bonding process? Why we need the bonding process, where we need this bonding? Any example of the device? In the video lecture also it is shown, na, where they used for soft lithography also, where they use the bonding process. Give me an example of a device where we go for the bonding process. Any of it. It can be anodic or intermediate layer bonding, or it can be direct bonding. But give me example where we go for the use this bonding process. Any of it. Vaishnavi?
No idea, ma'am.
Chetan?
Ma'am, no idea.
Okay. See, whenever ये cavity type portion ना, this type of figure, the cavity type portion like a piezoresistive or piezoelectric pressure sensor, so in between the structure there is a cavity type portion. So whenever the pressure is coming in on the diaphragm type of structure, then in the type of the pressure sensor, like there is a change in the voltage or the change in the resistance of the property. So there then how to uh, get the output, or how we will measure the output. So that's why in that case also the anodic type of bonding they used. So they have taken some glass or some another type of wafer, then they have made this bonding, the anodic or something else type of bonding, the intermediate or direct bonding. That's why in between this, or like some microfluid type of things, so there is a cavity. So the wafer where the cavity is present and some glass, so they bond it. Okay, so in that case the like an example is the piezoresistive pressure sensor, they use this the type of bonding. So in many cases also they can use the bonding where they want to group or stack the wafers or something else. Okay, so in that case they are using the bonding. So the right option is option D. Three types of bonding are present: anodic, intermediate layer, or direct bonding. So we are moving towards our last question, the question number 30. What is the true for DRI process? So what is the full form of the DRI process?
Deep reactive ion etching.
Deep reactive ion etching, which is a dry etching process. Okay, so the first option is enables a very high aspect ratio etch to be performed into silicon substrate. Second option is the side wall of the etch holes are nearly verticals, means this type of wet etching. What is happening, this type of figure, the angle between this is 54.7 degree. Okay, so for the dry etching this type of figure is coming out, the vertical wall, side wall. And the third option is depth of the etch can be 100 or even 1000 of micron in the silicon substrate. Or the fourth option is all of the above. So what is the right answer?
All of the above.
Okay, boy baby, what is the right answer?
All of the above.
Yes, the right option is all of the above. So we are ending the session here. So if you have any doubt, you can also ask me. And our next session will be happen next Tuesday 7 to 9 p.m. Okay. So do you have any question, or we are going to end the session?
No questions, ma'am.
Oh, okay, fine. So bye for today. We are going to
Thank you, ma'am.
end the session.
Yeah. Thank you, ma'am.
Okay, thank you.
Thank you, ma'am.